Today we are going to talk about simplifying expressions. So whenever we think about simplifying, just like with fractions, we're kind of making it smaller and easier to kind of look at, interpret, and to work with. So simplest form is when there are no like terms or parentheses in the expression. So I'm just kind of going through, and each time I'm just going to check, are there like terms? No. Are there parentheses? No. Then we're good. It's in simplest form. We can use properties to rearrange. Remember, we can kind of flip things around. The order doesn't matter as long as you are working with addition. Okay? So simplify the expression. Show all your steps. Some of them, it might just be one step right to the answer. Some you might need a step in between. So let's look at the first problem. If we've got 5x plus 3 plus 2x, okay? I want you to think about this. If we had tiles, so 5x would be like we've got 5 tiles, plus 3 would be a different color tile, and then plus 2x. So we've got 5 x's, 3 1s, and 2x. We are combining these into like piles. The greens are alike, or the x's are alike. So I could combine all of those together, which would give me a total of 1, 2, 3, 4, 5, 6, 7 x's and 3 1s. And if you think about it logically, if I think about the like terms here, 5x and 2x, they both have x. They are like terms. They can be combined. You have 5 x's and 2 x's, which gives you a total of 7 x's. The 3 can't be combined with anything else, so we just have 3 1s. So when I simplify that, I get 7x once I combine my x's plus 3. So let's look at another example like that. If we have 2x plus 2 plus 4x plus 3. So again, if we think about it with tiles, we've got 2 x's, 2 1s, 4 x's, and 3 1s. We're combining those that are alike. So I'm going to put the greens together, and I'm going to put the yellows together. Now I have 6 greens, or 6 x's, and 5 yellows, or 5 1s. So again, we're looking, are there like terms? Yeah. There are 2 x's and 4 x's, which make 6 x's, and there are 2 1s and 3 1s. 2 and 3, those are just plain old numbers that can be added together to get 5. All right, let's look at some more. Okay, example 3. We've got 4y plus 3x plus 2y plus x. And in number 4, we've got 5. Nope, we'll come back to that one. Number 3, 4y plus 3x plus 2y plus x. So again, we're looking, are there like terms? Yes. I see 2y, or 4y, and 2y, which can be combined together. That makes a total of 6 y's. And I see 3 x's and another x. Well, if I have 3 x's, let's say that greens are representing our x's, and we have another x, that combines for a total of 4 x's. Okay? Sometimes people forget. It's easy to look at this and say, oh, 4 plus 2 gives me 6. Over here, it's a 3 and there's nothing there. Sometimes people say, oh, well, 3 plus 0 is 3. But really, even though it's not there, using the multiplicative identity, that's telling us that there's 1 x. I have 3 x's and 1 x, which gives me a total of 4 x's. So don't make that mistake. Number 4, if we've got 5 plus x plus 2y plus 4x plus n plus 4y. Okay. Actually, one more thing I want to say about example 3. Technically, because it's addition, the order does not matter. I will tell you, though, that generally speaking, we put them in alphabetical order. So since X comes first in the alphabet, I would probably write this with the x furthest to the left. If you have this as your answer, though, that's totally fine, using that commutative property. All right, number 4, let's look. Are there like terms? Yes, there are. So I'm going to combine those that are alike. So I see an x, and I see 4 x's. Remember, even though there's nothing in front of this, this technically is 1x. So if I have 1x and 4 x's, that gives me a total of 5 x's. I also see that I can combine y's. I have 2 y's and 4 y's. Well, if I have 2 and 4, that gives me a total of 6 y's. Then I see that I've got a variable n. There's nothing else to simplify it with. There's no other like terms, so that's just going to be plus n. And I also see that I've just got a constant on its own, the number 5, with nothing to combine it with, so I'm just going to put 5. All right, number 5, 3x plus 3y plus 2. So I'm looking, are there any parentheses? No. Are there any like terms? Are there any other x's? No. Are there any other y's? No. Are there any other constants? No. So there's 2 ways that you could write your answer. You could either write it just as it was given. 3x plus 3y plus 2 is your simplified expression. Or you could write out the words simplified to notify that it is already simplified. So those are some basic examples of simplifying expressions. Now let's look at some where we're throwing in the distributive property as well. So for example 6, we've got y plus 3 times y plus 2 in parentheses. So if we think about the 2 steps that we look at for simplest form is that there are no like terms or parentheses. In order of operations, the first thing that we do is we always start with parentheses. It's the same way with simplifying expressions. We have to distribute first. So if I'm looking at this, I need to do the distributive property first. Remember, what that means is we take this number on the outside and we multiply it by each term on the inside to distribute equally. 3 times y would give you 3y. 3 times 2 is 6. You have to distribute the 3 to both terms. And then I'm bringing everything else down. Bring the y, bring the plus. Now we're back to kind of a normal simplifying expression that we've had before, where we're just looking for like terms. Well, there's a y and there's more y's over here, so I need to combine those. I've got, even though there's no number in front of it, this is representing 1y plus 3 more y's gives me a total of 4 y's. And then the 6, there's no other constant, so I'm just going to add the 6 there. Let's do 2 more examples and then some you try problems. All right, example number 7. We've got 7 plus 8x plus 2, and then in parentheses, 3x plus 1. So again, first thing, just like with order of operations, we always have to start with the parentheses. So I need to distribute. And the number that I'm distributing is the number that's just right outside the parentheses. So in this case, it's the 2. And I need to take that 2, and I'm going to draw those arrows to remind myself that I'm distributing it not just to the first number, but to the second number in there. So if I distribute 2 times 3x, we just do 2 times 3 gives us 6x, plus 2 times 1 is 3. Then I bring everything else down. Bring down the 7, bring down the 8x. Okay? Now we're back to a regular one where we're just trying to combine like terms. So I have a 7, which is a constant, just a regular number, and a 3. Those can be combined. 7 plus 3 gives me 10. And then I also have 8 x's and 6 x's, which gives me a total of 14 x's. I'm just adding the coefficients. 8 plus 6 is 14. Now, remember, you can leave it this way, Or generally speaking, we usually put our variables on the left and the constants on the right, but either one would work. Okay. Number 8, 7 plus 3 times, in parentheses, 5x plus 2, and then on the end, plus x. So we look, are there parentheses? Yes, that means we have to start with the parentheses. I need to distribute, since we're looking at variables here, and I'm distributing the number that's just on the outside of the parentheses here. So this 3 needs to be distributed. So I'm taking this 3 and distributing it to both terms on the inside. I take the 3 times 5x. 3 times 5 is 15x, plus 3 times 2 is 6. Bring everything else down. Bring down the 7. Bring down the plus x on this side. Now we're just looking for, are there any like terms? Well, we've got 7 over here, which can be combined with the other constant, 6. 7 plus 6 gives us a total of 13. And then we have x's. We've got 15 x's plus another x, which would give us a total of 16 x's, not 15, because remember, this technically is 1 x there. And then just like before, I can leave it like this, or the kind of algebraic proper way to write it would be with the variable on the left and the constant on the right. All right, I'm going to give you 2 you-try problems to do and get your answers checked. The first one is 4x plus 7 plus 3y plus x plus 11. Number 10 is 2a plus 9 plus 6a plus 5, and then in parentheses times 4 plus 2a. Go ahead and solve.